I did not. Our objective for today, I can solve and graph quadratic equations using intercepts and vertex. Let's read together. 1, 2, 3. I can solve and graph quadratic equations using intercepts and vertex. So far we've been doing just that. We've been solving and graphing. But today is going to be a special day because we add a couple more components to our graphing. And hopefully that'll straighten up our graphs and make them look a little bit nicer than some of you. Some of you, like, I don't know what you sketch, but they kind of look like parabolas. So today's one of those days where we have a lot of components and it's a lot of processes. So make sure, stay with me, please. Stay focused. And today we're introducing something that we call the vertex. We already talked about it briefly before, especially when I introduced the roller coaster. You can see the lows of the lows and the highs of the highs and so on and so forth. So we don't need a Frere model because we already know what quadratic equations are. Is that correct? Yes, Mr. Q. All right, good. We do need steps. So write these only 7 steps down, please. Yeah, I'm trying to crunch them as much as I can to like good manageable steps, but we know how each step is unpacked. So today's going to be, I think today's only 17 to 18 step problem. So I know our first step, make sure the quadratic function is in y equals ax squared plus bx plus c form. And that form is called what, everyone? Standard form. Thank you. So if you want to write SF on top of that or somewhere. Step 2, use the quadratic formula to find out the number of solutions. We briefly introduced that the other day, and we're going to do that today again. Bless you. Step 3, use the QF. What does QF stand for? Quadratic formula to solve for the x value of the vertex. I'll show you that today. Step 4, substitute the x value of the vertex into the function to find the y value of the vertex. Solve the equation, identify the zeros. We already know how to do that. Plot your y-intercept, your zeros, your vertex, and graph your function, and then we're going to sketch our line of symmetry. So one word that you see that's coming up a lot that is fairly new is which one, everyone? Vertex. So whenever you get to that part of the where you write vertex, make sure you write a little a bracket and write minimum and maximum. Maximum. And what is that? Highest, or I'm sorry, should use, what is that called in language arts when you match something up in a sentence? Parallelism or something like that? No, not paraphrase. Minimum is the lowest, or maximum is the highest point in the parabola. So in our graph, the vertex will tell us whether it's the highest or the lowest point. Remember, some of you asked me, Mr. Q, how are we going to know how far we go down on our graph before we come back up? Well, today's the day. Dun, dun, dun. Copy that, please. So 7 quick steps, but like I said, each step has like several steps, so we're going to try and keep it manageable. So let's go through the process. So underneath the steps, I want you to write example number 1. Example 1. And it says, example 1, solve and graph the quadratic equation using the vertex, x-intercepts, and y-intercept. And notice how I wrote here the equation y equals x squared plus 4x minus 5. I want you to write it somewhere in the middle, right here, somewhere in the middle, so you can leave yourself some space to the sides to do work. And also on your Cornell notes, today we're going to need a little bit of the Q column. You guys know how you have your Q column on the left side? you're going to use that space for something, and I'll show you that when we get there. I'll create a little space on my side on the left so we can use that for part of the process. Solve and graph a quadratic equation using the vertex, x-intercepts, and y-intercept. Okay? Bless you. And our equation is y equals x squared plus 4x minus 5. Okay? So, step 1 says, make sure that the equation is in y equals ax squared plus bx plus c form, which is standard form. Is it in standard form? Yes. Step 2. Read us step 2, please, Sergio. Loud. Thank you for reading it loud. So use the quadratic formula to find out the solutions to the equation. So underneath here, I'm going to write a little 2. I'm going to do this part in black. 2. I'm going to circle it so I keep track of what step I'm in. So I want to use a quadratic formula to find out how many roots. And like I said, we already did that the other day, so I'm bringing it back. So our quadratic formula is x equals minus b plus minus square root b squared minus 4ac over 2a. Okay? So we need to use the quadratic formula to find out how many roots we're going to get. We're going to predict how many roots. Focus, Santi. So I'm going to circle the discriminant. Do you guys remember what the discriminant is? It's the values under the radical, which is b squared minus 4ac, and I'm going to write those over here by themselves. B squared minus 4ac. Now that I have my little formula here, I need to substitute values from here and here. What is b? 4, so this is 4 squared minus 4. What is a? 1, and c is negative 5. Okay, so 4 squared is 16. Negative 4 times 1 times negative 5, that's positive 20. So this is 36. So what does this number mean? The number itself, it doesn't really have a value right now, but what I want to find out if it's either a positive, a negative, or a 0. Is it a 0? No. Is it a negative? No. It's a positive. That tells us that we're going to get 2 roots. You guys remember that? If that number ended up being a negative, if this was to be a negative 36, then we would get 0 roots or no solutions. If this number ended up being a 0, we would get 1 solution or 1 root. So this is just so notes for you guys, but here we can say that we're going to get 2 roots. Now, why did we do this step right here? Just to predict how our graph, so we can start picturing how our graph is going to look. We already know that we're going to have how many points on the x-axis? 2. So far, so good? All right. Step 3. Read us step 3, Sergio, loud. Okay. So, step 3. Use a quadratic formula to solve for the x value of the vertex. So for step 3, I'm going to write vertex, and I'm doing this in green. Can you turn off the left light, Crispy? Thank you. And open a parentheses. And we're going to find the x value, the one that goes on the left side of this coordinate. Yes? Now check this out. Look up to the screen. How do I find that? Well, I use the quadratic formula. Now check this out. Out of the quadratic formula, we already used one piece, which is the one in the radical, yes? Do you see anything else that we haven't used? This right here, right? I call this the California part of the quadratic formula. Do you guys see it? So I'm going to use this part to find the x value of the vertex. So I'm going to write x equals negative b over 2a. And that's going to give me the x value of the vertex. That means the x value of the highest or the lowest point on my parabola. So let's substitute values. What is b? 4 over 2 times 1. So this becomes negative 4 over 2, which is negative 2. And that is my x value of the vertex. Fairly simple? Yeah, right? Okay. Yes? No. You do need the vertex to find out what is the lowest point of your parabola. Because remember you guys asked me, how far do I go, Mr. Q, down here? Well, today's going to be the day that we find out how far you go. At that point is when you need to curve your parabola back up or back down. So here we go. What are we missing in this coordinate here, everyone? The y value. Look at our equation. What can we do with this equation and this x value to find our y? Substitute. So we're going to write here the original equation, y equals x squared plus 4x minus 5. And we're going to substitute the value of negative 2. So y equals, I'm going to open a parenthesis squared plus 4 parentheses minus 5. And I'll substitute in there negative 2 and negative 2. Let me zoom in. All right, so let's see. Y equals negative 2 squared is 4. 4 times negative 2, that's negative 8 minus 5. Y equals, let's combine like terms. Negative 8 and negative 5, that's negative, so we got 4 minus 13. And what is 4 minus 13? Negative 9. So that's my y value of the vertex. So now we have an x value, which is negative 2, and a y value, which is negative 9. So this is 1 point. Is that correct? So turn your paper over, go to the graph. Use one of the little graphs, and let's plot that vertex. And I'm going to do that in green to keep things separate. So negative 2, negative 9. Negative 2, negative 9 is down here. Plot your point. And on this side, I'm just going to write vertex. And I'm going to draw an arrow pointing to that green point. Negative 2, negative 9. Are we there? Can you guys see from back there? Okay. Do I zoom in? Negative 2, negative 9 is right here, and that's the vertex. Are we there? Okay. So let's see. The instruction says solve and graph the quadratic equation using the vertex. We got that. X-intercepts. So what do we need to do now? Find the x-intercepts, right? So check this out. What we're going to do, I want us to go to the Q side. You guys have this side right here on your problem, right? And I want you to rewrite this problem again, the equation, y equals x squared plus 4x minus 5. And let's find our roots. And let's see if we remember our process. Step 1, standard form. Is it in standard form? Yes, Mr. Q. No? You guys want to solve it using quadratic formula or completing the square? Factoring. Okay, so then let's substitute y with 0 equals x squared plus 4x minus 5. I'm going to zoom in so that you know where I'm at. All right, so then I'm right here. Man, it starts pixelating now. Do you guys see that? It's not that it's me. It's just the computer thing. X squared plus 4x minus 5. All right, so let's factor. Do we have GCF? No, so let's do negative 5 and 4 What factors of negative 5 add up to 4? Negative 1 and 5. So let's rewrite this. 0 equals x squared. What goes next? Negative 1x. What else? Plus 5x. What else? Minus 5. For those of you that forgot, remember that we're rewriting this, but instead of writing 4x, we write the factors that we found in here. All right, let's group this, these two and these two. GCF for these two, bless you, x, and we're left with x minus 1 plus, what is GCF for these two? 5, and we're left with x minus 1, and all that equal to 0. So our factors are x minus 1 times x plus 5, and all that equal to 0. And everyone, what is our next step there? ZPP, so set them equal to 0 and find our 0. So here we go. ZPP, you know me, x minus 1 equal to 0, x plus 5 equal to 0. So add 1, x equals 1, minus 5, x equals negative 5. Those are my x-intercepts, zeros, roots, solutions. So, can we plot this on our graph? Yes. X is 1 and x negative 5, so let me zoom out, turn it over, plot your roots. 1, and I'm doing this in blue so I can keep each thing separate. So 1 is one root and negative 5 is the other root. But we also need our y-intercept. Tell your neighbor the y-intercept, please. Negative 5, I'm going to do that in red. Negative 5 is down here. Okay. Now, before I graph my parabola, I'm going to do step 7 before step 6, before finishing step 6. Step 7 says graph your line of symmetry. Now, pens down, eyes up here. Now, line of symmetry is found everywhere, in everything, specifically in us. We have a lot of mathematics in our body. We have our DNA has mathematics, has a golden ratio. I think I introduced that at the beginning of the year. You guys remember that when I talked about that? Yeah, I think I talked about it. I said that if I was to have you measure the height, your height, divided by the distance from the top of your head to your belly button, you're going to get anywhere a number close to 1.1618, something like that. I didn't cover that? No. Okay, anyways, the golden ratio is in our DNA. But at the same time, our bodies are made symmetrical. What that means, if I was to draw with say if I was to go to Gianna and I drew with my permanent marker a line straight down her face like this, everything is equidistant from that line. So her eyes will be the same distance. Her ears will be the same distance. If she has a lump here, guess what? She's going to have a lump over here and stuff like that. So, same thing with the parabola. I don't know if you guys noticed, when we graph the parabola, it looks about the same one side to the other if I was to draw a line straight down the middle. That's what we call the line of symmetry. Now, the line of symmetry goes through the vertex. So watch. I'm going to draw my line of symmetry. The line of symmetry is going to go straight through the vertex, and I'm going to do that in green so you guys can see it. You see it now. So I want you to do the same thing. Draw a line of symmetry straight through the vertex. Doesn't matter where you start over here on the second quadrant, as long as it goes through -2 of the x value and goes through the vertex. Yes. Make it dotted, please. Now that I drew it, I'm going to zoom in really quick so you guys can see what I'm doing here. Now, look up, please. Now that you have your line of symmetry, this is going to tell us something about this parabola. Look up, please. Look up to the screen. Look at the roots. Look at this root on the right. How many steps is it away from the line of symmetry? Let's see. 1, 2, 3. Therefore, the other point should be 1, 2, 3. Now, do we have another point other than the roots? Yes, the y-intercept. How many steps is the y-intercept away? 2. Now, according to what we just discovered, that if there's a point 3 steps away from the line of symmetry this way, there needs to be another point on the other side. Therefore, if the y-intercept is 2 steps, guess what? What do you think is going to be on the other side? Another point, which is 2 steps. So plot that point in black. And now we have 5 points that can make our parabola a lot straighter and a lot more symmetrical. So check this out. So to plot our parabola, I'm going to do that in black. I'm going to start from left to right. Oh, by the way, looking at our equation, is it a happy or a sad face? Happy face. So we're going from left to right. And control your tick on your hand. Be a little bit more straighter on your curve. So here we go. Go through this point. Go through the point that was reflected from the y-intercept. As soon as you get to the vertex, you have to come back up. Go through the y-intercept, through the other x-intercept, and your arrows. Thank you. Damn, look at that. Look at, my goodness. I can sell that on eBay. I should make a shirt. Wow. Yes.
Can't you like just do it without doing all the extra work by just counting the step away? Like find the middle of the 2 points, and then that's your vertex.
And how do you know where the x's go? You see what I'm saying? Yeah. Give me a second. Hold on. Question was, can't we tell if it's a smiley face by the position of the vertex? Not really, because even if we put the vertex here, and let's say, look up, let's say this was like this, and I drew a parabola like that, could it still be the vertex? So how can we tell whether it's a smiley face? By the leading coefficient. Remember that? Yes.
Okay, what if the distance between the 2 x-intercepts was, then would the vertex have to be added too?
Say that again?
What if the distance between the x-intercepts is odd, then would the vertex have to be added too?
Yes. Yeah. The question was, what if the distance was 1.5 steps? Does that make sense? What if the vertex, instead of being here, it was at negative 1.5? Well, guess what? The other point has to be negative 1.5 steps. 1.5 steps to the left. Does that make sense? All right. So with that said, let's try another one. So lengthy process, yes, but doable, right? So here goes the process once again. Let's see if we got it. Step 1, is it standard form? Yes. Step 2, you write your quadratic formula and use the discriminant. I'm going to label that discriminant so we can remember. Discriminant. We use the discriminant to find out how many roots we're going to have and predict already in our brain how our graph is going to look. Step 3, we're going to find the vertex. How do we find the vertex? We use the beginning part of the quadratic formula to find the x value. That goes in there. To find our y value, we substitute that x value into the original equation, which we did. That's how we got our y value. We plotted that. Next, we need to find our x-intercepts. Do we know how to do that process? Yes. That process we already know we can do either by completing the square, quadratic formula, or as we did here by factoring. Are we there? Once we plotted those 2 points, we drew we plotted also our y-intercept, which was the constant here, -5. We drew our line of symmetry, and I'm going to label that just to make sure we have it. Line of symmetry. Line of symmetry. All right, and then from the line of symmetry, we can see that the y-intercept is how many steps away from it? 2. So therefore, on the other side, I plotted another point that was 2 steps away. Okay? Yes.
Why is the line of symmetry dotted?
So that we don't get it confused with an actual line that we're working with. That's just kind of like an imaginary line, so we do it dotted. All right, let's do example number 2. So if you don't have space there anymore, turn it over. You have space in the back. Example 2. For example 2, same instructions. You don't have to rewrite the verbiage anymore. Just write the equation. Y equals x squared plus 6x plus 8. And I'll give you a head start to see how you do by yourself. Okay? Go through the steps and see if you can find me how many roots we're going to have at the beginning. Find me the vertex, the x-intercepts, the y-intercept. Draw your line of symmetry and give me one more point. And then from there, graph your parabola. Ready, go. Step 1. Is it in standard form? Yes. Step 2, I'm going to use the quadratic formula. X equals negative b plus minus square root b squared minus 4ac over 2a to find out how many roots I'm going to get, right? But I only use the discriminant. And I saw some of you, are you going to solve using the quadratic formula? That's fine, I mean, if you're going to do that. B squared minus 4ac. So what is b? 6 squared minus 4 times 1 times 8. So this is 36 minus what? 32, and that gives me 4. Therefore, it's a positive, and it's 2 roots. That's how many roots I'm going to get at the end. Is that correct? So this doesn't help me other than to tell me how many roots. Step 3, I'm going to find the vertex. I need an x and a y value. So for the x value, I'm going to use the, like I call it, the California part of the quadratic formula. X equals negative b over 2a, which is negative 6 over 2 times 1. This is negative 6 divided by 2, which is negative 3. That's my x value. Hands if you got that. Okay? From there, I need a y value. What did we say? Let's use the original equation. Y equals x squared plus 6x plus 8. And then we substitute y equals parentheses squared plus 6 times parentheses plus 8. And inside of the paren, we got negative 3, negative 3. So this becomes y equals 9 minus 18 plus 8. Combine like terms, y equals 17 minus 18. Y equals negative 1. Hence we got vertex negative 3, negative 1. That is correct. Negative 3, negative 1 is right there. Next, I'm going to solve for my x-intercepts. So I'm going to rewrite that equation, which is y equals x squared plus 6x plus 8. And like some of you were using the quadratic formula, you can solve it by the quadratic formula or by factoring. X squared plus 6x plus 8. Power Rangers, that's 4 and 2. Anyways, to make a long story short, x equals negative 4, x equals negative 2. Those go right here, negative 4, negative 2. My line of symmetry. Idalis, what is my y-intercept? 8, which is here. How many steps is 8 away from the line of symmetry? 3, which means on the other side, 3 steps away is another one, which is right here. Therefore, my parabola looks something like that. Hands if you got that by yourself. Good. Home plate for tonight is found on page 617, evens. and you're going to do this exact process. Even though it doesn't say it there, I want you to use this process for those 5 problems. Have a good one, guys. Your home plate. See you guys tomorrow. Bye.